Take a minute of your time and imagine the world without mathematics. Teaching platform, this is Mr. Mlonga, aka the teacher. My pupils calls me the teacher. We are here to do mathematics indeed. Be ready for the lesson that is coming forth. If you are new to this channel, you are welcome. Please subscribe so that every time we post a video, you are the first to be notified. We'll be posting videos every day. This is a product function and it has to be integrated with respect to x. So the first step, look at the powers of the trig functions. This is to the power 2. The one with the highest power, equate it to u. So you say, let u be equal to sine x. So in place of sine x, we are going to write u. Then differentiate this u with respect to x, such that you have du over dx is equal to, when you differentiate sine x, what do you have? You actually have cos x, like that. At this point, this can also be written as a fraction. When you write it as a fraction, cross multiply. When you cross multiply, you're going to have du is equal to dx cos x, like that. At this point now, divide throughout by cos x. So you say cos x, even there, cos x. When you do that, this cos and that cos are going to cancel. So what do you have? You actually have dx is equal to du over cos x. After making dx the subject of the formula, go back to the question. So we have the integral of 2. Remember, this sine is equal to u, but this one is to the power 2. So it will be 2u to the power 2, then cos x times du over cos x. I'm talking about this because this dx is equal to what we have here. So in place of dx, we will write that. This is what we've done there. Then at this point, cos and cos will cancel because this is a numerator, that is a denominator. After doing that, you are going to now have 2u squared du, because this cos have cancelled. Then from there, you say you can now integrate, because these 2 can be written outside. You just write it as 2, then integral of u squared du. You are now integrating this u squared to the with respect to u. So what do you have? You have 2, then the integral there, when you integrate, it will give you u to the power 3 over 3, like that, then plus c. After doing that, this u, you know it, u is sine x. So meaning you're going to now have 2, then open brackets, this is sine x. This 3 and that 2, they can form a fraction, so you write it like that. Then u to the power 3, that is sine to the power 3, then x plus c. This is the integral we were actually looking for. On the solving board, we have a question 2, where we have to evaluate. When you're asked to evaluate, it means they're asking you to find the final value. But first of all, we need to know what is this and that. This is the lower limit and that is the upper limit. So to provide the solution, we can say let 1 over 2x be equal to u. So let u be equal to 1 over 2x. After letting u be equal to that, find du dx. Du dx is going to be equal to 1 over 2. You have just differentiated there. Cross multiply at this point. You are now going to have dx is equal to 2 du, like that. So after doing that, you can now substitute back into the question that you started with. So we are talking about the integral of, there is a 0, there is a pi, then over 2, then cos 1 over 2x is equal to u. So we have u there, then dx is equal to that. So you write 2 du. After doing that, you can multiply through at this point. There's nothing to cancel. So you say 2, then the integral of 0 pi over 2, and then cos u du. After doing that, you can now integrate this. The standard integral of cos u is going to be sine u. So what we have after integration, we are going to have 2, then 2 sine u, then you have the limits, that is 0 pi over 2. At this point, we know the value of u. This u is 1 over 2. So you say 2, then times sine, that is 1 over 2 x, and the limits there, 0 pi over 2. At this point now, you have to substitute the limits. This is the upper limit. You start with the upper limit. So we have that is equal to 2. Then we are going to substitute through. We have sine 1 over 2. X is equal to the upper limit, which is pi over 2. Then minus. At this point, you have substituted the upper limit. Now the next is to substitute the lower limit. So the lower limit now is going to be sine 1 over 2. The lower limit is 0, so you put a 0 there and you close the brackets. So you are no longer going to be writing the upper and the lower limit because you have substituted. So it's more like upper minus lower. This is what we have done here. Then from there, you can say 2, open brackets, this will be sine 1 times pi will still be a pi. 2 times 2 will give us a 4. Minus. This whole thing becomes a 0. Then at this point, this is pi over 4. It's more like 180 divided by 4, which is going to be 45. So we are more like saying 2, then sine 4, 5 degrees. This is a 0, so it will not change anything. What is sine 45? It's actually 0.707. So what we have 2 times 0.707, which will eventually result into 1.4141. We have another question on the solving board. Evaluate this. So if we have to evaluate, then we should get to the final answer. What to do first of all, look at the trigonometric functions. The one with the highest power is tan. So we'll say let u be equal to tan x. After that, differentiate this u. You say du over dx. What do you get? It will give you sec squared x. When you differentiate tan x, it goes to sec squared x. Then make du dx. Make dx the subject of the formula, not du. When you do that, because this is over 1, cross multiply. When you cross multiply, you find dx is going to be equal to, because this would actually divide du over sec squared x, like that. So this is your dx. If that is your dx now, you can substitute back into the original. So say the integral of, this is pi over 4, then 0, 2 will still be maintained, but tan is equal to u. So it's u to the power 3. So 2u to the power 3, then sec squared x the way it is, but this dx is equal to that. So you multiply, you say du over sec squared x. At this point, this sec squared x and that sec squared x can be cancelled because this is the numerator and that is the denominator. So from this point, we can write these two outside, then integral of the limits will still be there, pi over 4. What have we remained with here? This 2 is there. These have cancelled, so you have u to the power 3, then du like that. At this point now, you can integrate. So if you have to integrate at this point, then you have this 2, which is this one. Then you open the brackets. What is the integral of u to the power 3? It's actually 1 over 4 u to the power 4. Remember, you have the limits 0 and pi over 4. So from here, you can now substitute for u, because this u is tan x. So you are going to have 2, open brackets, then 1 over 4, tan x. Tan x, this is raised to the power 4 because of this, because of that. It's raised to the power 4 because of that. Then you have the limits 0, pi over 4. At this point now, you have to actually substitute the limits and subtract them. This one here, this 1 over 4 and that 2, they can form a fraction. You say 2 there, 1, 2 there, 2. So what comes out is going to actually be 1 over 2, then open brackets, tan x. So we are saying tan. Our x, we are going to consider the upper limit, that is pi over 4 to the power 4 minus, we are now substituting the 0. That one also be tan 0 to the power 4, then you close the brackets there. After doing that, tan pi over 4 is more like tan 45, which will give you 1. So what you have 1 over 2, then open brackets. This is going to be 1 to the power 4 minus tan 0 is equal to 0. So 0 to the power 4, like that. When you do this, then I'm sure the answer will just be 1 over 2, because what you have is 1 over 2, then times this is 1 to the power 4, which used to be 1. So the answer is 1 over 2. This marks the end of our lesson. Please, if you have not subscribed, this is the time to do so, because every day we'll be posting videos, and it's important that every time we post a video, you are the first to be notified. Where you need to comment, you need to ask something, do not hesitate. We value your support, we value your contribution, be it positive or negative. Welcome once more, and thank you very much for having watched the video. Please share the video with others. Let other lovers of mathematics enjoy the mathematics that we are doing on this platform. It's mathematics all the way until Jesus Christ comes. Take a minute of your time and imagine the world without mathematics. We cannot be able to calculate or count the time without the use of mathematics. The calendar that we use is a product of mathematics. We only get to know that this is the year 2020 by the use of mathematics, by following the calendar mathematically. The population of any country is a product of mathematics. You only get to know that it takes 9 months for a baby to be born through the use of mathematics. In the medical field, temperature is calculated using mathematics. In the business world, profit and loss is only appreciated by the use of mathematics. A bricklayer uses mathematics to calculate the number of bricks needed for that construction. A carpenter uses mathematics to calculate the gradient of the roof before the roof is put up. A policeman has to count the number of prisoners in that police cell through mathematics. A thief should be able to calculate the hypotenuse of that brick wall before falling off that brick wall. We all need mathematics. Mathematics runs the world.